All right, so James, Ismael, Mana, Ari, they all said it's 79.8 is equal to XY. Okay, so just a clarification, when you enter answers in Schoology, we all want answers in standard form. Okay, if you were with me last year, you know very well what that means. You have to place your variables, okay, on the left hand side and the numbers on the right hand side. All right, so XY is 79.8. Thank you. All right, let's have another example. And then we'll give you some time to try the other ones on the right hand side. So in the second example, point M is the midpoint of VW. So following the same statement that we wrote earlier, we can write the two little pieces that form, the entire segment VW. So we can have VM plus MW is equal to VW. So you can start with that, right? Or um, as an alternative, if you know that M is the midpoint, then you can actually also write VM is equal to the other part, which is WM. Okay, so I put these two examples side by side to kind of differentiate when to use this type of equation, this one, okay, and when to use just making them equal to each other. So if you're looking for the entire line segment, right, it helps to write this long equation here. But if it's just asking for the length of a portion, okay, like VM, it says find the length of VM, then what you can do is just make the two equal to each other because M is the midpoint. So going back here, by substitution again, we can substitute 4x minus 1 for VM and then substitute 3x plus 3 for MW or WM. Okay, and if you notice, I said WM or MW interchangeably because when you write a name for a segment, it doesn't matter where you start, right? Questions? Would you like to help me now? What's the value for X? Either type in the chat or unmute yourself. So what is X equal to?
4.
4. All right, so X is equal to 4 because you subtract 3x from 4x, you'll get 1x, and then you have to add 1 to the 3. Okay, now we don't stop there because what we need to find is VM. And VM is represented by 4x minus 1. So what are you going to do with the value of x?
Substitute.
Yep, we're going to substitute. And Ori, that was right. It was 4. Now James said we're going to substitute. So 4, change x to 4, okay, and then take away 1. So what will be your final answer? 15. All right. So VM is 15. Okay, so now it's 1:28. I'm going to give you about 6 minutes to do these two examples on your own. Okay? So at 1:34, I'm going to give you instructions on how you write down your answers. Okay, start on this page. Last 3 minutes. Last 3 minutes. 2 minutes. One minute left. For the first question, there could be, multiple answers in identifying the segment by sector. So just be aware that there's not just one answer. Okay. And if you would like to share, please let me know or raise your hand or unmute yourself. And I'm going to make you a temporary co-host so you can share your screen. So in other words, if you wrote, okay, hang on, honey. If you wrote on your slide, you can actually share that screen with us. Or if you wrote on a piece of paper, you can actually show that in your camera. I'm going to allow those who will share to be co-hosts, but I just want to remind you that you're not being recorded in Zoom, but I am screencasting, so we're just gonna stick to what's school appropriate, okay? All right. Any volunteer who would like to share? James, you wrote 3.66. Would you like to share how you got that?
So PM
Okay,
is
hang on.
1.8.
Hang on. Did you write something on your screen or on a piece of paper?
Well, I just did in my head.
Okay, go ahead. Explain, please.
So P to M is 1.8 millimeters. So the other side, I'm pretty sure that it's the same amount.
Okay, so you mean MQ?
Yes.
Okay,
And if you add those together, that makes 3.6 millimeters.
all right. So that's for PQ, right? Now, how about the other one? Identify a possible segment by sector. So what,
Oh, I didn't
yeah,
see that part.
that's okay.
I think
So
it's T to M.
TM. All right. You have to start with M though because it's the end point. It's the midpoint, right? Okay. So you could say MT. It could be a segment. It could also be a ray MT. Yeah. And it could also
Yes.
be point M. All right. We can't use a line because it did not extend to the other direction. Thank you, James. Yes, Ricardo. That's awesome. It's 3.6. Cool. All right. Who would like to volunteer next for the second one? Let me know. You can be the co-host so you can share the screen. Anybody? If you wrote something on a paper, you could just put your notebook next to your camera so we can see. Ricardo, would you like to share?
Yes.
Okay, so I'm gonna make you A co-host. Okay, I'm looking for you. Hang on, honey.
Oh,
Uh,
I didn't write anything.
oh, okay. All right, cool. So I'm
I
gonna.
like I could share my screen with the notepad.
Oh yeah, sure. You could do that.
All right, cool.
Give me one sec. I'm trying
Yeah, me
to.
too. I need to make a note.
Sure. I'm trying to find you in the chat so I can make you a co-host. Here you go. More and then make co-host so you can share your screen with us.
All right. Wait, wrong screen. Here's. Where is it? Where's
At the bottom of your Zoom, there's like a green button, share screen.
Sorry, it's just asking to use like my system preferences and stuff.
It's
Never mind. I won't screen share them.
nope. No,
No.
you could just click on the first option, which is normally the entire screen. Does it work or no?
Hmm. Uh, let me try.
Yep.
Just top one.
Yep.
Share that.
It's the very top one
Uh,
normally. And let's see. Just give it some time and okay, we don't see it yet. Did you click on it? Did you click OK?
uh, dang. Yeah, no, it's just trying to give me a bunch of other stuff.
Oh, okay.
I can't screen share. Sorry.
Okay, it's okay then. Give me one sec. I'll share my screen again. Hopefully next time we can make it work. All right.
Sorry.
Okay, that's fine. You know, it's our first time to do it as well. So now I'm just gonna follow your thoughts, honey. I'll write for you as you explain. Okay.
All right. M represents the midpoint, meaning it separates the lines into two congruent, meaning it is literally the middle, meaning that 3x minus 4 is equal to 2x plus 1. So you take away 2x from both sides, leaving you with x minus 4 and 1 equals 1.
Okay. So there's a one over here, and I had to move the four over, right?
Yep, so then you get x equals 5.
Okay. Let me just clean this up a little bit. So you said x is equal to 5.
Then you substitute 5 into back into the equations. 3 times 5 is 15, minus 4 is 11. And since you know that it's exactly half, you just multiply 11 by 2.
Okay. So this is also
And you can
22.
check by, what is it, substituting it into the other equation. Add
Okay.
them together, 22.
That's awesome. All right. So make them equal, substitute into the expressions, or Ricardo said, I know M is the midpoint, so that means it will be also 11 for the other part. Okay, that's cool. Thanks, James and Ricardo, for sharing. All right, now let's move on to our next slide. Were you able to screenshot this one if you needed it before I erase it?
Yes.
Okay, cool. I'm gonna clear. Then let's move on to the next slide. Okay, so in slide 6, we are going to talk about the midpoint again, but this time, if you know, it's not horizontal, it's not vertical, but it's going to be a diagonal line with either a positive or negative slope. So you will be doing something like this in delta math as well. So I thought of um, showing you one already right in delta math. Okay, so find the midpoint of points A, -8, -2, and B, -5 and -7 graphically. So we're going to study it first graphically before we go algebraic. So the first point is -8, and then 2 down, and then now we go to -5, and then -7 down. Okay. All right. Okay, so in your interleave warm up, you're actually looking for a slope. Um, so what we're going to do here is we're going to draw a rectangle such that this segment is the diagonal of that rectangle. So we're going to start from either vertex and start at the other. Okay. So now that you see that rectangle, to find the midpoint, you can actually count the number of boxes, which is 1, 2, 3. So the middle portion here is somewhere between, these two numbers. So it's 1.5 units, right, from the endpoint. And then if you count vertically, it's 1, 2, 3, 4, 5. So half of that will be 2.5. So I go 1, 2 units and a half. All right. So then you can have, like a quick estimate of where the midpoint is. So if we write down the answer, the x value there is negative 6.5, and the y value there is about negative 4.5. Oops. Okay, and then submit our answer and click yes, and you got it right. So that is the graphical representation of a midpoint. But not all the time, we have to graph it. So we also have a way of finding the midpoint just by doing it in our heads. And what is the formula we're going to use? It's this formula over here. Now, this formula, I would like you to think of it as an average. Now, why average? Because it's just asking you to add two numbers and then divide by 2. X1 and x2 are pretty much, the x coordinates of the 2 points, while y1 and y2 are just the y coordinates. So you add them up and then divide by 2. So let's try to do that here in this example, and then I'll make you do this one over here. Okay, so the endpoints of RS are given, and we need to find the coordinates of midpoint M. So M will now become, to find this number, you add the x numbers together. So that's 1 plus 4, and then divide by 2. Then when you're done, you now add the y numbers together. Okay, so we get negative 3 plus 2, and then divide by 2. That's why I said it's just the average. So your final answer will now become, this will be 5 halves if you want to keep it in fraction form, and this will be negative 1 half. Or you could say 2.5 and negative 0.5. Okay, so can I give you about 2 minutes to do this? One more minute? Now, would anybody like to share or screen or explain that I write? Just let me know so I can make you a co-host if you can screen share and volunteer.
I would like to share.
Okay. Um, make co-host. All right. I'll stop my sharing and you should be good to go.
I don't have any.
Oh, okay. I forget. Okay, here we go. Here we go. All right. So,
So for AB, I got 4, 4 comma 5. for
Okay.
the coordinates.
Okay. So for this one, for M, you said what? 4, comma 5. Would you like to share how you got that?
So I added 1 and 7 divided by 2, and then 2 and 8 divided by 2, and then 4 comma 5. That's it.
All right. Cool. Very good. Does anybody have a question about how to find the midpoint when the two endpoints are given? Nope. Okay. Now we're going to change the given information a little bit. This time, the midpoint is already given. So you know that the answers are 2 and 1. Now only one endpoint is given. So in other words, you have an x1 and you have a y1, but you don't have the x2 and y2 for the other endpoint. So how are we going to do it? So I'm going to show you how to do it algebraically, and then later on we're going to talk about some shortcuts. Um, okay, so since your first number here is 1, let's go 1 plus the other missing number, which we don't have. And then remember, the formula says you have to get the average or divided by 2. So now you have to get this guy by itself. So what do you do with the 2? You cross multiply there. 2 times 2 will be 4. So 1 plus x2 is equal to 4. And then you have to subtract the 1 from 4. So you will get x2 is equal to 3. All right. So following the same procedure for the y coordinate, your y number here is 4. You're going to add it to the missing y value, and then you divide by 2. You're supposed to get 1 because it says the midpoint has 2 1. So do the same thing again. 2 times 1 is 2, and then you subtract the 4, so you will get negative 2. All right. So some shortcuts there is, if earlier we were adding and then dividing, so pretty much we undo the operations, right? We undo them, but we have to follow PEMDAS. We have to do the M or D first before the add and subtract. So pretty much, if you know the endpoint, you multiply it first by 2, and then you subtract the other endpoint. Let me say it again. If you know the midpoint, you multiply it by 2, and then you subtract the other endpoint. So now with that, I'll give you 2 minutes to try the last example. And let me erase this one. Can you take a picture of it if you need it? Because I have to erase it. So I'll give you 2 minutes to work on that. I'm clearing the ink. And somebody's ready to share?
I would like to share.
Game.
So I got 3 comma 7.
3 comma 7. Please explain.
So I'll have a work to show, but
How did you do it? Just explain it
uh,
in your own words. Yep.
so I just saw that the midpoint is 2.2 comma 4. So I was just thinking, okay, what would get what what other endpoint would get the like thing to there? So
Mm-hmm.
I just So if I split something by two,
Uh-huh.
like if I divide something by two, what would give me two? And if I divide another thing by two, what would give me four?
Okay.
And so I was basically just working in reverse in my
Yeah,
head.
working backwards, trial and error. Cool. Yeah. So if I could give like a structure to that, so you multiply the midpoint by 2, so 4 times 2, which is 8, but you have to subtract the given y value, which is 1. So that's how you got 7, right? And then if you
Yes.
double this, that's 2 times 2, 4, and then you subtract the given x value in the in the endpoint, so that's going to be 4 take away 1, which is 3. All right, so which is quite the opposite of what we were doing here. We add and then divide by 2. Well, here we multiply by 2 first and then we subtract, so that's in reverse order. All right, so I do hope that those gave you examples on how to find the midpoint. I'm going to erase this and show one in delta math. So okay, back. Now let's do the midpoint formula. So find the midpoint of the segment with the following endpoints. So this is the regular type of problem when the midpoint is the one missing. So what are you going to do? You add them up, right? You add these two together, and I think somebody had the answer in the chat. And okay, James said 3, 3, so you add them up, 6, and then you divide that by 2, which is 3. And then now you add these up, same thing, 6, and then you divide by 2, which is 3. So your correct answer will be 3. Okay, and then submit it. All right. And again, be mindful of the order. Addition is commutative, but what makes this, you know, I said like do it in order because the very first numbers will give you the x coordinate of the midpoint. So if you switch them around, if the numbers are different, then you might get wrong. Okay? All right. Now, last but not the least, okay, here we go, is distance, which we pretty much saw when we were in middle school. I'm not sure if you guys were familiar with this, but we'll see. Now, in middle school, we talked about the Pythagorean theorem, right? Okay, maybe you're wondering, all right, so why do we have a formula that doesn't look like a squared plus b squared equals c squared, right? So the distance formula is actually the same as, the Pythagorean theorem. So why? Because if you get the difference between these 2 points, the horizontal line, right? If we call that A, right? And then you count the number of boxes from here to there, you're going to call that B. To find the distance that you're looking here on the diagonal, looking for in the diagonal, that's just actually the same as the C value. Okay, so for some students, they say, oh, the distance formula is so complicated. It has a square root, etc., etc. But you've done that before. It was just, it just wasn't called the distance formula, but they called it the Pythagorean theorem. Okay, so let's try. Um, it says here the endpoints of AB are 1 and 2. So first I'm going to show it algebraically, okay? But if you want to use the Pythagorean theorem where you have to plot it, right? Okay, so let me show first how to do it algebraically. It's similar to the midpoint, but instead of adding them, you have to subtract. So let's say these are the first numbers, the x values. If we write AB equals, now don't add them, instead you're going to subtract them. Doesn't matter where you start, it doesn't really matter. The formula starts with x2, okay? But you can switch them around. So I'm going to go 1 minus 7 and then square it. So the reason why it doesn't matter, or the order doesn't matter, is because 1 minus 7 is 6. When you square it, 1 minus 7 is negative 6. When you square it, it's 36. But when you start with 7, 7 minus 1 is also 6. when squared, it still becomes 36, right? But if you start with this number, okay, then when you do the y coordinates, you have to follow the same pattern. Start from here. So plus, okay, let me finish this and then I'll look at the chat. 2 minus 8 and then squared. Okay. Square root of 72, which you can further simplify, James, because that's not in simplest form. So going back here, we get AB equals, so we said that this turns to negative 6 squared, which is 36. And then 2 minus 8 is negative 6 again. When you square it, it's also 36, which gives us what James got, which is square root of 72, right? However, okay, now if it's a double number like this, I would strongly recommend that you don't multiply or you don't add them right away. Instead, you write them as 36 times 2. So what's the purpose for writing it that way? Because if you have a 72 and you're not very familiar with all the perfect squares, you probably will, need a calculator to break that down already. But if it's 36 plus 36 written as 36 times 2, isn't 36 a perfect square? The square root of 36 is actually what? It's 6, right? So then that goes out of the radical sign already because it's 6. And then the square root of 2, that's not a perfect square, so it has to stay under the radical sign. Okay, and this is the final answer in simplest radical form. Okay, if you change it to decimal, I don't know what that is in decimal, but you can do it in a calculator. So from radical 72, you can change it to decimal, but if the instruction says in simplest radical form, then you have to do it like this, okay? So what if I have a 48? How do you simplify radical 48? Okay, so we did this in Algebra 1 last year. So what's that biggest perfect square number that goes into 48? Anybody? I'm going to write it over here. Anyone? How do you simplify square root of 48? Okay, what are your perfect square numbers? Starts with 4, 9, right? And the chat goes, use 4. Yeah, we can use 4, but that's not the biggest perfect square number that could go into 48. I'm not saying 4 is wrong. You can break it down into 4 times 12, but you have to break down the 4 again. So what's the next perfect square number to 9? 6? Try again. Yeah, 6 goes into it. 16. Yeah, but we're trying to find the perfect square numbers that could go into that, right? So 4, 9, 16. 48 is 16 times 3. So what's the square root of 16? That's 4. So it now goes out, right? The other 4 just disappears. And then you bring down the radical 3. Now, I want to show you when, okay, Mr. Arciaga, what if I don't know my radical numbers? What am I going to do? Okay, you can actually answer the same thing by starting with smaller perfect number. Let's say 4 goes into it. So 4 times what is 48? Then you're going to say, oh, 4 times 12, right? But then you're going to break down that 12 again. So that's your first 4. 12 is 4 times 3. Now you see that group of 4 right there, which made the 16 originally, right? And remember, for every pair, you take one out because 4 times 4 is 16, and the square root of that is just 4, and then you take the other 4 out. So you will end up with the same answer, which is 4 radical 3. There you go. All right. So let's just look at one last example and, oh, how do I erase this? Clear ink. Okay, so we have here an example in which your school is 4 miles east and 1 mile south of your apartment. So what does that mean? We're going to assume that, your apartment will be at the origin. Okay. So that's the beginning point. So if you say, let me draw something here. Now, The faster way you could do this is you go to Desmos if you want to. Desmos.com or GeoGebra. I showed you last time how to do it, right? Desmos.com or GeoGebra. Okay. So the school is, let's label them north, south, east, west. So if I'm at my apartment, I go 4 east, so 1, 2, 3, 4, that's positive 4. 2, 3, 4, and then 1 mile south, so that's negative 1. So I'm going to be here. So 4, negative 1. Then a recycling center, which your class is going on a field trip, is 2 miles east, so 1, 2, and then 3 miles north. 1, 2, 3. There you go. So the recycling is 2 miles east, 3 miles north. So now estimate the distance between the recycling center and your school. And just like what I said earlier, if you are more familiar with the Pythagorean theorem, this is how you can do it. You make a triangle, right? From here to like right underneath the other point. I'm sorry, it's not straight. Okay. And then now you count the number of boxes there. 1, 2. So that's 2, right? Well, where did that come from? It's actually just the difference between 4 and 2 here. 4 minus 2 is 2, right? Okay, now let's count this. 1, 2, 3, 4. Where did that 4 come from? It's 3 minus negative 1. 3, it's 3 minus negative 1, so it turns 3 plus 1. Yeah? So either you're doing this or you're counting the triangle, you're getting the same answer. So to find the distance, we're just going to find the value of c, which you guys are more familiar with. A squared plus b squared equal to c squared. So your a is 2, or you can interchange these, it doesn't matter. So 2 squared plus your b is 4, so 4 squared equals, we're looking for c, so 2 squared is 4, then 4 squared is 16, which is equal to c squared. So now we add them up, it's 20. But that's not simplified. So what are the factors of 20? The factors of 20 are 4 times 5. So 4 is a perfect square. So that means our final answer will be 2. Yeah? So no more. And then the square root of 5 stays inside the radical sign. Okay, so 2 radical 5 miles. Okay, so you've seen two ways of finding the distance between 2 points. If you prefer doing it algebraically, you could follow this formula. If you have time to graph the points, you can also use the Pythagorean theorem. So at least you have two ways to pick from. Your Delta Math homework will be on these topics, midpoint and distance, and they will be due next Monday. Yep. And again, please take time to do the interleave warm-up on finding slopes, and you can find some notes on that, some review materials on that in the lesson 1.3 notebook that I made you download today. So this will be your interleave review for today. And if I may, no, sorry, I can't because the grades are showing. But yeah, if I may remind you of your missing work, or maybe I could do that. Let me just hide if I can hide the, okay, if I can hide the total, okay, hide grading, hide calculated grade core. Okay, so if I can hide that, then I can show you the grade book. Um, so let me